Hi everybody, how are you? It's good to see you again at the beginning of a new month. And I wish you a very happy new month. So we resume from where we stopped the last time. We started to talk about arrays, and we say that arrays give us the chance to store more than one item inside of a single variable. So these values are spread on the computer memory. Also, we said that arrays are homogeneous, which means the values that are stored in an array in C must all be the same type. So if you create an array to store an integer, all the items in the array must be integers. And we denoted that by writing the type in front of the name of the array. And this was where we started from last. So we also discussed single dimensional array. And we said that we write the type, and after the type, we write the name of the array, and we define the size of the array in square braces. So we said we define the size of the array in square braces. And this means that we are creating an array named X, which would contain 5 items, and the 5 items must all be integers. This is the meaning of that. So we said that for this array, it's going to look something like this. It's going to have space for 5 items. So it's going to have space for 5 items. 1, 2, 3, 4, 5. And additionally, we said that our arrays have zero-based index, which means the index starts from 0, goes up like that, till it gets to the size of the array minus 1. So it stops at 5 minus 1, which is 4. And this is this dimension of the array. But one thing we need to observe is that we provided just one information while creating this array. Why? Because we need only one dimension. We need only the dimension along the horizontal axis. Um, but there are times that we need something more than this. There are times that we need arrays that are bigger than this. And today we go to arrays that are bigger than this, called multi-dimensional arrays. The previous array we had was in just one dimension. But today we want to extend it to the next dimension. And by the way, we can have much more than 2 dimensions. That's why we call it multi-dimensional arrays. So we can have many dimensions. But the idea is we'll focus today on just this type, the 2-dimensional array. Something like this. Okay, forget about the quality of my drawing. If you understand, then it's good enough for me. Okay, so the next thing we now need to identify is the fact that these arrays should have dimensions, and the dimension to go on both axes. So let's start with the slide. An array may have any number of dimensions. We have discussed one dimension, but today we go to others. The following declaration creates a two-dimensional array. What do we mean by 2 dimensions? In the x-axis and y-axis. So if you look at it mathematically, this is the x-axis and this is the y-axis. The y-axis is called the row. So this is one row, this is another row, this is another row, like this. And the x-axis is called the column. Yep. So here is a two-dimensional array with this dimension. So M, which is the first part, is the whole R, and this is the second part, which is the column. So automatically, if you see this notation and you see M2, 3, it simply means that for the array named M, you would have 2 rows and 3 columns. So in this situation, M has 5 rows and 9 columns. If you check, we have 9 columns. This is length minus 1. This is 5 rows, which is length minus 1. So if you count, you have 1, 2, 3, 4, 5. 5 rows. To access the element of M in row I, column J, we must write M, I, J. So if you want to get an element in, let's say, um, if I want to get an element that is here, what is the row of this place? It is 2. What is the column of this place? It is 6. So if, let's say the name of this array is M, if I want to get an item that is kept here, then I have to say M. Remember, a row comes before column. So you write M2, 6. If you write this in a print statement that is well defined, it would print for you whatever value. Let's say X that is here. Okay, the expression Mi designates row I of M, and Mij selects column J on row I. Resist the temptation of mixing them together. Don't do this. It is wrong. Don't mix them together. Although we visualize two-dimensional arrays as tables, that's not the way they are actually stored in computer memory. C stores arrays in what we call the row major order. Okay, so C stores arrays as row major order. Here is what that means. So if we have an array, let's try to draw a little array. I think it would be nice to have a good color. So let's say this is our array. Yes. So we may be tempted. Okay, before our temptation, let's try to make a very lovely array. Usually, what do I use? Is it this? I think this. And then I select the first brush. Bam. Yes. So we can actually draw our array like this. Let's just make it a very small array so we don't have to spend a lot of time. So we make it a small array. Let's define the rows as green. So this is row 0 and this is row 1. Let's define the columns with blue. This is column 0 and this is column 1. Now, this is what we want to believe that we have in the computer. But the truth is that we don't have it as a box in the computer memory. Why? Because the computer memory is not a box. The computer memory is a straight linear arrangement from location 0 to the size of the memory. So it is impossible to have a box. Actually, the memory of the computer is open like this. So how is this box stored on this computer memory? It's simple. We have 4 boxes here. So let's make 4 boxes here too. Bam, bam, bam. So everything will be stored here. But here is what I want you to observe. We say they are stored in row major order. And that means we pick them row by row and we put them in this place. So what happens is we take this row first. We take this row first and we move it to the computer memory. So we put it here. And then we take this row next. We move it and then we put it here. So what we are calling row major order is that we pick items row by row and we move them into the computer memory. So this place is 0 to row, 0 to column, and because of that, this place is going to be 0 to row and 0 to column. This place is going to be 0 to row, 1 column. So it's going to be 0 to row, 1 column. This is 1 row, 0 column. So this place is going to be row 1 and column 0. And this is going to be row 1, column 1. So we are going to have row 1, column 1. So this is how we save multi-dimensional array in memory. In different languages, we have different structures. Some other languages have column order, but C makes use of row major order. It takes row by row. So with row 0 false, then row 1, and so on and so forth. Nested for loops are ideal for processing multi-dimensional arrays. And here is an example. We want to initialize an array for use as an identity matrix. A pair of nested for loops helps us to do that. Why? We go through the array and then we check wheresoever the value of row is equal to the value of column, that is the diagonal of the matrix. If you think about that, it makes sense. What is an identity matrix? Identity matrix is a matrix that has zeros and just one in the diagonal. So this is it. Here is an identity matrix. So it should have 0 everywhere, and in this diagonal, it should have 1. So let's make it have 1 in the diagonal. Now, this is where we will have 1, else where we have 0. Let's forget about the 0 now. Let's just think about how can we put 1 in this place using code? This is 0, 1, 2, 3. This is 0, 1, 2, 3. So if you make observation, you realize that every place that we have 1, the row value and column value are the same thing. Whenever we have 0 and 0, we put 1. Whenever we have 1 and 1, we put 1. Whenever we have 2 and 2, we put 1. Whenever we have 3 and 3, we put 1. And this is what we call identity matrix. Other places will have a 0. And that is the way you should think when you are programming. So here, this is a macro, and then we create an array of size 10 and 10. So this is a 10 rows, 10 column matrix. We define variables that would hold our current row. And then we say for row is equal to 0, row is less than 10. We know that it stops at n minus 1. And then we increase row. Now we are at row 0. We are checking for column is equal to 0. So we have picked this row. Next thing we want to do is now we want to start from column 0 and go from left to right. So we say for column 0, column is less than the number of columns, and then we increase column. Here is the important part. Here is important. Here is the important condition. It says check the value of row and the value of column. There are times that the two of them will be the same. Like at the beginning now, the two of them are the same. Whenever they are the same, put 1. If they're not the same, put 0. So what would happen? For this, you would have 0 in the other places. Because the other places cannot have their row and column values like. Yep. So we can create an initializer also for a two-dimensional array by nesting one-dimensional initializers. Um, if we have 5 rows, we can say this is row 1, row 2, row 3, row 4, row 5. If you have 9 columns, we can put 9 elements inside of a single dimensional array and put that as the element of row 1. And this is acceptable in C. Initializers for higher dimensional arrays are constructed in a similar fashion. What does higher dimensional mean? It means that we have a third dimension. 1, 2, 3. So this is for array A that has 3 dimensions. We can have 5, 4, 7. Oh, so this is the row, this is the column, and in many programming languages, we call this the page. What is the page? Okay. C provides a variety of ways to abbreviate initializers for multi-dimensional arrays. If an initializer is not large enough to fill the array, then the elements that are left are given 0. So here we have defined a 5 rows array, but we have provided only 1, 2, 3. The remaining 2 will be automatically filled by zeros by the C compiler. Now, if an inner list isn't long enough to fill a row, that is, if you put the items during initialization inside of curly braces, this is important because you can actually fill the array without putting them in inner curly braces. You could use only this one and just write all the 5 times 9 elements in the system, the parentheses. It will automatically fit them in position. But if you put inner braces, you have specifically told the compiler that this is row 1, this is row 2. So that way it treats each row independently and can count the number of columns in the row that you have given to it. So it can count, this is 1, 2, 3, 4, 5, 6, 7, and 8. Oh, 1 is missing. So it automatically puts 0 for that one and move these curly braces here. For this, it puts 0 also. Everything that is not available, it puts 0. This is important. It puts 0. So it automatically initializes with 0. Next, we can even omit the inner braces, which is what I just told you now, that you can actually remove all of these inner braces. You can, including this guy, you can remove all of the inner braces. This brace, you can remove all these braces, and this, you can remove all of them, and just leave the ones we check the end of the last one. So let's assume you should have 45 in this case. If you have 43, and in your own mistake, the 43 was lost, 2 were lost in row 1, the compiler does not care. It shifts everybody left side and puts the remaining 2 at the end of row 4. So you have to be really careful if you are trying to do that. So once the compiler has seen enough values to fill one row, it begins to fill the next row. Now you should be careful that omitting the inner braces can be risky because an extra element will affect the rest of the initializer. So if you put one extra element inside of it, 5 times 9 is 45. Instead of you to put 45, if you put 46, your program will crash. because it does not know what to do with the last one. Or if you miss one, okay, if you miss one, it is still better. Actually, missing one is still better, because if you miss one, since the compiler knows the length of the array, it just helps you to fix 0 at the end and you are fine. So an array can be made constant by starting its declaration with the word constant. Remember the structure for array. It should be type of element in it, the name, and then square parentheses that can or do not need to contain the size of the array. If you want to put the size, if you don't put the size, the compiler will automatically calculate the size based on the values you assign. Okay, but we are expanding this policy now because there are times we want a constant array, which means we initialize it at the beginning, and we don't want anybody to ever be able to change these initializing values. Nobody should be able to change these values. And so to declare this kind of array, we have to put the keyword const in front of it. So we must be able to tell the compiler that this is a different kind of array and it's called a constant type of array. So this is a constant array. With a constant array, we can protect our values better than in other type of array. An array that has been declared const should not be modified by the program. This is important. If you have defined an array as constant, it means automatically you must initialize the value right from the beginning. And that means you have initialized the value. It is a constant. You must not change it again. So for this kind of array, if it is defined as a constant, you must not have this kind of expression. Observe what I'm trying to write now. You must not have this kind of expressions. So in the name of the array, let's say location 2 in the array is equal to something. This is illegal. A constant array must never, under any circumstance, be on the left-hand side of an assignment operator. It must never. It can be on the right-hand side. That means it is providing value to something on the left-hand side. Or it is providing value to a function. Like if you put x chars 2 inside the print statement, it only picks what is in location 2 and prints it. But if you put it at the left-hand side of an assignment operator, it means you want to save something in location 2. The compiler will reject. So your code will not compile. This is really important. Okay. So, any question? No question? Advantage of declaring an array as a constant. Okay, we already know the advantage. The advantage is that we don't want to change the array. We want it to be fixed. We don't want the values to change. So advantage of declaring an array to be constant is it documents that the program won't change the array. Now, in your mind, you could create an array and you know that you won't change the content of the array and you write the code. It's fine. But the increased benefit of declaring it as a const is that anytime you look at the code, you can remember that this place must not change. Anytime another programmer looks at your code, they don't make changes to that part. They don't put it on the left-hand side of an assignment operator because it is a constant. So it passes a message to you and to anybody reading your code. And then the second but most important thing is that it helps the compiler to catch if you make a mistake. If somehow you try to save something to any location in that array, your code will never compile. Your code won't compile because constants are meant to be protected. So constant is not limited to arrays. It is useful in array declaration, but we use it in many places, All right, so we finish this chapter and we move to our final chapter. Any question before we end this chapter? All clear. Okay, that's good news. If it's clear, I'm happy. All right. Do you want a break? Do you want a 5 minutes break and then we go to our last chapter? Yes, you want a 5 minutes break. Okay, 5 minutes break. That will be by 9:35. We resume. All right, you're back. It's sufficient time for you to have a cup of tea. So, functions. You have written basic codes, at least up to this point. But somehow you have used functions. You have used group of codes that assist you in doing a task. And these are functions. A function is a series of statements that have been grouped together and given a name. Okay, but what do we mean by group together? They are put together inside of some kind of categorization and given a name because that is what you call it with whenever you want to use it. So an example of a function that I'm sure you have seen is the print function because you have used the printf several times. Printf is a function. Functions usually have parentheses in front of them. Each function is essentially a small program with its own declarations and its own statements. Its own declarations mean you declare variables inside of it, and then you have statements that operate on these variables. Advantages of functions. A program can be divided into small pieces that are easier to understand and easier to correct later if you want to correct it because you didn't write everything as a single file. You wrote everything as small files that can call each other to complete their task. So with functions, we avoid the problem of duplicating code. So if you look at many programs I've shown to you, you have seen printf used many times. But what actually is happening inside of printf, you don't know. I just put %g and then I write something and it works. The reason is because the printf function has been written somewhere, and instead of me writing its code again, I am not writing the code. I'm just calling it. So I'm using it more than once. A function that was originally part of a program can be reused in other programs. This is another advantage of functions. Very soon you begin to write programs and you would be familiar with functions. You would realize that by having a function, it assists you to apply the idea inside that function in many assignments. So here is a function called average. Remember here we said that it's a series of statements that have been grouped together and given a name. So let's start with the name. Look here. This is a function called average, and this is the name. Also, we said they have been grouped together. This is a function called average, and it has items inside of it that have been grouped together using the braces. We said it has its own declaration and then its own statements. In this one, we have its statement. We don't have new declarations here because it doesn't need new variables. Okay, so let's begin to explain this function. The first thing you see here is a statement called a word called double. Double here means whenever this function completes its job, it needs to tell the person who asks it to do the job something. It needs to provide the person with its result. And that result must be of type double. This is the meaning of this. That whenever this average method completes its average function completes its job, it needs to send a value back to the person who gave it these two values to work on. And the value it returns must be a double. Your result of average must be a double. This is number one. Number two is the next thing. You know this by now. This is the name of the function. Next thing is parentheses. This parentheses contains what we call parameters. We put parameters inside of the parentheses. So here we have one, two parameters. Let's explain the parameters also. Now, looking at the first one, we see double and then we see a. What this means is this function average takes a parameter. The name of the value is a inside of this place. Inside of this place, the name of the value is a. So that means this guy is this. But keep in your mind, inside of this place, the name is a. Not outside of the entire program. Just inside of this place, the name is a. The next thing is this double. This double means whenever anybody wants to use this function called average, the first parameter they provide must be a double. That's the meaning. The first parameter they provide must be a double. The same thing is for B. B is the name of the second parameter within the scope of our function. That means this guy is this. And it also must be a double. Every function has an executable part called the body, and that body is enclosed in braces. That body is enclosed in braces. So it has an executable part, a part that can be executed. The body of average consists of just one return statement. Look here, the body of our code is just this line, and this line actually is a return statement. On the other hand, we can expand this code to something else. We can expand this code and make it to be longer than this, to be more than one line. So I can write this code as this double average double A double B. Okay. So I can say int C. And I can say C is equal to A plus B divided by 2. Actually, let me put some space. Yes, so this is C. Then I can say return C. This makes sense. So this way, we have expanded the body of our function to have 3 lines. This is a declaration of a new variable. This is an assignment statement that does the addition of A and B and divides the result by 2. Then it assigns the result of the entire arithmetic expression to C, and then it returns C to wheresoever we call average. Executing this statement causes the function to return to the place from which it was called. This is a very important concept. Whenever we execute this line, we just come into the body of the function. We execute this line, we create a variable called C, execute this line, we assign a value to C, but whenever we execute this line, control jumps away from this average function to wheresoever it is in the main function that we called average. So let's expand our code. We can say int main so we can say int D is equal to 4 and G is equal to 6. So in the next line, we can say printf percentage %d, and then we can compute the average of G and D. Okay, let me not start it this way. I think I'm making it too advanced for you. I can say int W is equal to average D and G. So what is going on? Now, this is the main function. Okay, let's just complete this and complete the code. Now, this is the main function. In the main function, we have a variable called D with the value 4. We have another guy called G with the value 6. So we take D, we send it into average. What does that mean? G and D here are arguments. Arguments to the function. So we send D. What is the value of D? D is 4. So it's like we are putting 4 here. We send G. G is 6. And then we send 4 and 6 into average. What does that mean? D is 4. And we said that the first parameter is A. So 4 moves inside of A. 6 is copied inside of B. So we have 6 plus 4 divided by 2. That will be 5. We put that in C. We return 5. So what happens is this. The moment the compiler control, it returns C. Execution jumps away from average and it jumps back here. And it appears as if this entire expression is replaced by the value of the expression, which is 5. I mean, it doesn't change your code, but this is essentially the effect. The effect is that the entire expression that sent us out of main into the function called average is completely replaced logically by the functional value of average, which is 5. So again, I told you that inside of here, A and B are parameters. Please keep this in your mind. A and B are called parameters inside of the function where they are defined. But inside of the main, where they are calling the function, they are called arguments. Please keep this in your mind. Okay. So executing the return statement will take us back to the place from which we called the average function. And then it will take the result and put it there. So the value of the expression will be the value returned by the function, which is 5. A function call consists of a function name followed by a list of arguments. Okay, nice for you. I already showed you an example. So a function call is the name of the function followed by its arguments. Okay, I told you already that these are arguments. These are parameters. So you shouldn't get confused. Okay, average x and y is a call of the average function. And we have put x as an argument and y as the second argument. Arguments are used to supply information to a function. So here is the call average xy causes the value of x and y to be copied into parameter a and b respectively, not randomly, respectively. X, which is the first parameter argument, goes into the first parameter. This is important, not into the second, not into anyone. It goes into the first one, and the value in y goes to the second one. Please keep this in your mind. The value in y goes to the second one. An argument doesn't have to be a variable. Any expression of a compatible type is okay. So an argument doesn't have to be a variable. You can plug in your physical values directly and the code will still work. We'll put the call of average in the place where we need to use the return value. So here is an important thing. Where do we need to use the return value? Okay, we need it here by assigning to W. But we can actually have a different way. We can actually use this average right at the place where we want to use W. So we can actually completely remove this line and bring the entire expression here. Because what we need is the result. We don't actually care about the expression. So we put it here and we use the return value here. All right. Um, so here is a statement that prints the average. Oh, nice. We already did the same thing. So you can understand easily. So the return value of average is not saved here. It is not saved into W like we did before. The program just prints it and throws it away because we are not saving it. If we had needed the return value later in the program, we could have saved it somewhere like we did before, save it in W, and then we can use W for printing, but W still helps us to save our value. The average.c program can read three numbers and uses the average function to compare their average one pair at a time. So this is another average function. This average function accepts three numbers and then it computes their averages. So this computes the average of every value passed to it. But observe, we are calling average with the three elements. We are calling average with the three elements separately in different print functions. Okay, so um, yes, I need a task from you. You have a classwork immediately, and it's graded. So I want you to change this function. Okay, let's start with you write the function. I want you to make a copy of this function inside of your compiler. You can use Dev C++, you can use online GDB, use whatsoever it is that works for you. Let me open online GDB. Okay. Okay. So this is the online GDB compiler environment. Go to onlinegdb.com and on the right hand side, change the language to C. So you first write your code here. I'll expand your task later for you. But at the beginning, you just write this. Just copy this code and put it there. I give you 15 minutes. 15 minutes should be fine for you. So please do that and then I'll come back. You will share your screen. So please know that now. You'll share your screen. I'll see the code you wrote and I'll ask you questions. Remember, we're in the last chapter. You need to learn. All right. Yeah, it's possible. Okay, next person, Umejan. Umejan, share your screen. You didn't understand percentage G. Okay, let Umejan share his screen. Umajan, will you share your screen or you will not share your screen? It seems Umajan will not share his screen. Let's move to Onur. Onur, share your screen. Let's see your task. Okay, let's see if, okay. I can't see anything, it's dark. So probably you should share again. I can't see anything. Okay, so what was the question? You didn't understand percentage G. Okay, we talked about percentage C, percentage S, percentage D, percentage F, LF. G is just one of them. G helps us to display decimal. So it can display decimal, it can display exponentials, which we cannot do in the other types that you are familiar with. So that is just the some importance of G. Okay, it seems it's only going to be Omar that would share a screen. So we continue from here. Okay, general structure of the function. I'll share my screen back and we can continue. So, general form of a function. By now, you should already know, I explained to you the first one that was double. I said it is the return type. The second is the function name. And then inside of the parentheses, we have the parameters. After that, we have a curly brace that defines the body of the function. And in this body, we have declarations, which would be declaration of variables. Like I think we have here, we have the declaration of a variable, and then we can have other statements. We can have other statements. These are the other codes that are available in the function. So the return type of a function is the type of value that the function sends back to where it is stored. So rules governing return. Number one, it cannot be array. You cannot return an array. Specifying that the return type is void indicates that the function doesn't return a value. So sometimes you have to write, instead of double, you have to write void. So void here means that whenever this function average completes its execution, it would not return anything. So this line must not exist. This return must not exist. So what can a function that does not have a return value do? It can print. So we can have print C. So it means it prints the C and we are satisfied with what it did. So this is a void function. It doesn't return anything. Okay, specifying that the return type is void indicates that the function doesn't return a value. If the return type is omitted in C89, the function is presumed to return a value of type int. So if you didn't write the return type, then the compiler assumes that it's an integer. After the function name comes a list of parameters. So we talked about this also earlier, the list of parameters. Each parameter is preceded by a specification of its type. Parameters are separated by commas. Parameters are separated by commas. If the function has no parameters, the word void should appear between the parentheses. So again, if you have a function that can do its job without having a parameter, something like this. A is equal to 5, G is equal to 7. So because we already have A and B, then we don't need to get A and B from outside anymore. So this function would be void. The body of a function may include both declarations and statements. Yes, we already saw this. Declaration and statement. A function call consists of the name of the function followed by a list of arguments. A function call consists of the name of the function followed by a list of arguments. Okay, I think we changed our code and we remove that. But by the way, you should still remember we discussed it. A function declaration provides the compiler with a brief glimpse at a function whose definition will appear later. Okay, now if you look at the example we wrote here we wrote the function up before writing the main. Okay, this is nice. In this case, it will be easy for the compiler to handle it. But normally, you don't write all your functions up. You write your functions down in the code. So, to assist the compiler in identifying your function and being able to know what the function should do and what the function must not do, we provide it the first line of the function. We copy this first line and we bring it to the top. So the compiler should see this part. This is what we call the function declaration. So we are declaring the function to the compiler that, okay, sometimes later in this code, we are going to meet a function called average. The function does not take any parameter. The function does not return any value, but its name is average. So we just put that. And this is the general form of a function declaration, the return type, which is void. The name of the function, which is average, and the list of parameters that are available for the function to execute. And if the function doesn't have a parameter, we replace this with void, also in the declaration. If the return type isn't existent, because it won't return anything, we replace this also with void. The declaration of a function must be consistent with the function's definition. So what it means is that here, if you wrote int, the compiler shouldn't get down in the code and find the function having void. So you must make sure that everything is the same. So here is that average program again, but now we have added the declaration. We've put the first line of the function up in the main program. Observe. This is the declaration. The function itself is down in the code, just like what we have here now. The function is down in the code, but we have put the declaration up. So this way, this line tells the compiler that, okay, there's a function inside of this C file, and that function is going to be named average. It's going to take two parameters. The two parameters are going to be double and double. And when the function completes its execution, it's going to return a value which is going to be of type double. Function declarations of the type we are discussing are called function prototypes. So this line, which is called declaration, is also called a prototype. It's also called a prototype. So the prototype is just like a picture of what the compiler would see sometimes later. C also has an older style of function declaration in which the parentheses are left empty. So the idea is that you put the parameters inside of the parentheses. But in olden days, they sometimes remove these parameters. Just leave the parentheses alone. A function prototype doesn't have to specify the names of the function's parameter as long as their types are present. Okay, so instead of double A as we have in this instance, in fact, the compiler can see only the type of the parameters. It doesn't essentially need to see the name of the variable. Why? It doesn't need to see the name of the variable because it doesn't make a difference. The name of the variable only has effect inside of the function. So A only has effect here, B has effect here. It doesn't essentially matter. The key thing the compiler needs here is the relationship between this average method and the outside world, the average function and the outside world, which in this case is the life in the world of main. And the main thing that connects average to main is the type of parameters it will receive, and also at the end of the day, what kind of return value it will send. So those three must always be put: the name of the function, the return type, and the type of the parameters. The name of the parameter does not matter because the name of the parameter here is not the same as what we will have in main. Let's check. In main, we are calling average. The parameter is A, but here it is X. So you see, it doesn't matter. Here it is Y, even though it is B here. It doesn't matter. The key thing that matters is that this X, is it type double? So we check. X is double, Y is double. This is the part that matters. It's usually best not to omit the parameter names. Okay. Okay, let's go to arguments. Now, in C, arguments are passed by value. What passed by value means is this. If you look at this program, we are sending the value of X into average. X is going to become A. But the key thing you should know is that the value X itself does not go into average. What goes into average is the value inside of X. So if the value inside of X, let's say it is 4, 4 is taken from X and put into A. 4 is the value of X. So we say we are passing the value of X to A. So what it means is, if inside of this double, if we have something like this, A plus equal 1, what does that mean? It means we increase A by 1. That means A becomes 5. But because X is passed to A as value, 4 is taken from X and put inside of A, it means this change to 5 only affects A. It cannot affect X. This is the important reason why we discuss pass by value. The key reason why we discuss pass by value is to make students to know that variables are passed by value, except you specifically pass the entire variable. There's a different way of doing that. You have not learned it. But whenever you pass a value, a variable to a function, normally you're just picking the value inside that variable and putting it into the parameter of the function. The variable outside does not change whenever the value changes inside of the function, because we only passed the value, we didn't pass the entire variable. But on the other hand, if you look at this line, I just want to introduce you to something else that you will see in the future or very soon. Observe that when we pass parameters to this, we put ampersand in front of X, ampersand in front of Y, ampersand in front of Z. This is not passed by value because we are not passing X to the scanf function. We are passing the address of X. This ampersand means address of. It is called the address of operator. So it passes the address of X into the scanf function, making scanf able to change X. So scanf changes the value inside of X. But observe what we are doing here. We are passing only X. And that is why average cannot change X. Observe, average is a function with parentheses, the same way scanf is a function with parentheses. The two of them are equal, they are functions. But the difference is that average does not need the address, it receives by value. Scanf needs the address. All right. So when the function is called, each argument is evaluated and its value is assigned to the corresponding parameter. Now, since the parameter contains a copy of the argument's value, any changes made to the parameter during the execution of the function does not change the argument. In fact, the fact that arguments are passed by value has advantage. Okay, sometimes it has its advantage, but it has its advantage. And one of the advantages is that since a parameter can be modified without affecting the corresponding argument, we can use parameters as variables within the function. So we can use that parameter as variables within the function. We can define X outside and also X inside of the function, because we know that the function does not care about the hex outside. It will not change it. Okay. Okay, this is just to explain the same thing. Now, I think we can see a disadvantage. C's requirement that arguments be passed by value makes it difficult to write some kind of functions. Now, remember that we have a policy. In C, a function cannot return two values. It can only return one thing. Which means whenever you have a function that modifies a variable or modifies two variables, we cannot return the two. And this is a disadvantage of pass by value because we can't modify the two, we know, but and we can't return the two, but we should be able to modify the two and somehow let the changes we did in the function affect the variables also outside. But this is normally not possible. So this is an example. We have a void function, so it is not returning a value. The name of the function is decompose. It takes one, two, three variables. So what is this? Double x is a double variable. Integer part gives us the integer part of the variable. So let's say x is let's say x is 8. It's really difficult for me to write it. Probably I'll switch to another number. Let's say x is 7.132 if this is x. And this is the double x. So we pass this x into decompose. What we are planning to do is remove the integer part. So we put 7 here and we want to put 1. Okay, this is double. So we have to put 0.132 here. Okay, it is fine. We can do that. We can say we convert x to an integer, a long integer. What happens? It cuts away the floating point part. It removes it. But the problem is that after we remove the floating point part, it becomes just integer 7. We put that inside integer part. And then we subtract everything. We remove the integer part from it. It gives us the 0.132. We put it in fractional part. But we are stuck. Why? Because we cannot return two things. We can return only one. So how do we get the fractional part? You write another function and get only fractional part. It's not correct. It's waste of time. So this gives us a big problem with C functions and pass by value. So the other idea is pass by reference. What I showed to you here is what we call pass by reference, but it is not within the scope of our course. Actually, it's not in the slide, but probably if as you're studying software engineering, you would learn it later before you graduate. We have pass by reference. Okay. Argument conversion. C allow function calls in which the type of arguments don't match the type of parameters. Remember earlier we said that make sure that the prototype of the function meets the type of function you actually defined. They are the same thing. But when it comes to the parameters and arguments, we can have differences. So if we have a function that accepts a double, you can pass an integer to it. What happens? It will promote it to a double by adding zeros to the back. So C allows function calls in which the type of arguments don't match the parameter. The rule governing how the arguments are converted depend on whether or not the compiler has seen a prototype for the function or the function's full definition before the call. So when a function's parameter is a one-dimensional array, now we are talking about passing an array to a function. Observe that in the declaration you put the braces, also you put the square braces. This is important. When you are creating an array, you put the square braces in the declaration. So observe that the length has not been specified. C doesn't provide any easy way for a function to determine the length of any array passed into it. Instead, we will have to supply the length if the function needs the length as an additional argument. So what that means is um, there is no direct function in C that can calculate the length of an array. In most other languages like Java, like Python, the length of an array is known. It's the property of the array. So if you write, let's say the name of the array is A in Python, if you just write a.length, Python automatically knows the length. It tells you the length. But it's not the same with C. There is nothing to get the length of an array in C. But I remember I taught you the size of operator. So you can use the size of operator to calculate it inside of the function. Or you can calculate it outside and send the size as an integer parameter into the function. So you can send the size as int n as an integer parameter into the function. Okay, so here is the same thing using int n. So the guy computed the size of the array from outside, and then he passed the size of the array directly into the function. And because we have changed our function to look like this, the first line looks like this, then it means our function declaration or prototype will become this. It is no longer this. It is no longer this, because with this, you don't know the length, you don't have full information about the array. So the prototype must be the exact first line of the function. So this is the prototype. And again, if you like, we can remove the name of the parameters while we are creating the prototype. Though we say it is not the best practice, but why not? Since the compiler doesn't complain. Okay. Any question? Any question? We are getting close to finishing. Any question? No question. That's good. Okay, so now let's continue. We have defined the size of our array. We have created the array based on that size. We created an integer variable also, and we want to calculate the total of the array. So we call a function called sum array. We provide it the array called B, and then we send the length of the array into that function. So it's important that you observe something. Sending an array to a function or calling a function that uses an array as a parameter is not different from calling a function that uses normal variables. Observe that B, when you are calling the function array B, is not including the square braces. We don't put this. Observe. This is important. Don't put the square braces when you call. If you do this, it will be wrong. Also, a function does not have a way to be sure that we have passed it this correct length of the array. So let's assume that we made a mistake and we sent 30 as the length of the array. The function cannot know that 30 is smaller than B. Why? Because there is no function in C that can automatically know the length of an array. So it is important that you are very careful when you are passing the length as a parameter. It's important. Though it is good that you can pass the length and the compiler isn't sure if it is correct or not, because you can use it to cheat the compiler. You can give an array of size 1000 to the compiler and tell the compiler that it is of size 10, and it will believe you because it doesn't know otherwise. It only knows what to tell it. So a function has no way to check that you have passed it the correct array length. In fact, we can exploit this fact by telling the function that an array is smaller than the array really is. So let's assume that you have an array of size 100, but we have put only 50 items in it. It means we can tell the compiler that, oh, forget about that array size. It is size 50. And the array will believe us and will use only the first 50 spaces. And this way we will avoid having a problem with trying to read what is in like location 51 because it doesn't, what is there is garbage. Now, be careful not to tell a function that an array is larger than its real size. This one is dangerous. The compiler can create an undefined behavior. It can misbehave because you are making it to read from an uninitialized location. You will have undefined behavior. Undefined behavior means it reads something that you have never seen before and it prints it as a value. A function is allowed to change the elements of an array parameter, and the change is reflected in the corresponding argument. So this is really a different shift from when you are passing a variable, a scalar variable as a parameter. Now, if you pass a scalar variable as a parameter to a function, we discussed just about 5 minutes ago that anything you do in the function cannot change it. But if you pass an array, anything you do in the function to that array will change the array inside of the function and outside of the function. So if you pass an array, okay, let's use this example. So this function stores 0 by the name. It receives an array and also it receives the length of the array. So it receives an array and also it receives the length. So observe what is going on. For I is equal to 0 till I is less than n, that means start from the first location and stop at the last location less than n. Set all the values there to 0. So it goes through the array from the first location to the last location and it sets the values to 0. If you call this function on an array and you pass the array and its size to the function, it will change everything in your function. It will delete, it will change everything in your array from whatever value was there to 0. So it is important that you understand that when arrays are passed to a function, the function can change the values in the array. Okay, if you want the explanation, they say it's in chapter 12, but I can explain to you. The explanation is that we have something called pointers. Variables are normal variables, but because an array is not a scalar variable, it's a list of many spaces in memory. So an array is not a normal variable. An array is called a reference type because it refers to many locations. And this is the reason why the compiler on the function call can change it. Why? Because you cannot pass all these locations to the function. What you just have to do is pass the entire array. And in passing the entire array, you have to hand over the address of the array to the function. So actually, even though you are seeing B sent here, what actually is going on is you are actually sending the address of B to the function. And because of that, we are not copying the array. Previously, we were copying the value of variables into functions. But for arrays, we are not copying arrays. We are using exactly that array in the function. So any changes made to the array in the function will appear also outside of the function. Okay, this appears to be pretty straightforward. A non-void function must use the return statement. So if you have a function that is not void, then it must have a return keyword somewhere in its body because this is the only way for the function to terminate. the function terminates at the return keyword. A void function terminates at the closing braces. A void function terminates when it hits the closing braces of the function. But a non-void function, that means that returns integer, returns double, must terminate with the return keyword. So if there's no return keyword, you'll have a problem. Some compilers will not even compile at all. Okay. If the type of expression in a return statement does not match the function's return type, the expression will be implicitly converted to the return type. So what this means is in your function declaration, if you defined the function to, let's say, return an integer, and while you are trying to return, you are doing something that is different. You are writing return C, okay, but C is defined as a double. So what would happen? By policy, C will be forced to become an integer. So we will implicitly convert C to become an integer. So let's say the answer in C was 5.94. By the time we hit this return, it changes it to 5 because it needs only the integer part. Okay, here is the explanation. If a function is asked to return an integer, but the return statement contains a double expression, the return statement contains C is a double, the return statement contains a double expression, it's returning C, which is a double. The value of C is forced to become the type of the return, which is int. Return statement may appear in functions whose return type is void. Okay, if you like, you can put return inside of a void function. It doesn't matter. The compiler will just ignore it. That's the meaning. The compiler would just forget about it because the compiler knows it is void. A return statement may appear at the end of a void function like this. But using return here is unnecessary. I mean, it is useless. If a non-void function fails to execute the return statement, the behavior of the program is undefined if it attempts to use the functional value. So let's assume the function does not have any value to return, but somehow you are trying to catch a value. Okay, let's take, for example, we have this guy. Let's make it void again. So we have void average C. And after computing C, our next job was we printed C. So we don't have any return here. But unfortunately here, we are waiting for a return value. What will happen? Okay, we have changed the code. What will happen? The compiler will be waiting for a value of W, which should be returned by average, but average doesn't know that it has to return anything. So there is going to be a problem. And since there is no way to handle this issue, we say that the behavior is undefined. The compiler would do any kind of strange thing. All right, so that is the end of our course. So I would love to ask if you have a question. Any question? Anything to let me know? Anything to ask from me? Okay, in that case, let me ask you, how was the summer semester? How was the class? Were you able to learn? Hmm, that's great. It's all right. So please begin to prepare for the examination. We already fixed the date. Try to study. You would have to write more code than what you did in the midterm in the finals. So please make sure you prepare for the examination. Prepare very well. I wish you the best of luck. Please write present in the chat before we close our meeting for today. By tomorrow, I would announce your attendance grades. And again, as I said, the attendance grade is going to be strictly by you writing present. There won't be any argument after the semester that, oh, Jam, I was in the class, didn't you see me? No, I won't be seeing anybody. I would only be seeing present. So please write present now. This is 10:47. I'll close the meeting by 10:48.